guys, so we will solve another question regarding priority queue. So here we have max value equation. So we are given an array of points represent the x-axis and the y-axis of a point on a 2D plane. So the points is actually sorted by the x value, means that xi is smaller than xj for every pair of ij, right? So we are also given an integer k. We need to return the maximum value of the sum of y value and then the difference in x value, such that the difference in x value is smaller or equal to k. Okay, so it is guaranteed that there exists at least one pair of points that satisfy the constraint, right? So first thing, since the x-axis is sorted, we actually have to make sure that we use this, right? We have to make sure that we use the fact that the x-axis is actually sorted. So what does that mean? We will actually consider every point to be the ending point of the equation, right? So for example, if we consider this as the ending point of an equation, we will have to compare it to this guy and this guy, right? But since both of these guys are actually does not satisfy the constraint, since 5 minus 2 is larger than 1 and 5 minus 1 is larger than 1, then this is no longer a validated candidate. So how about this guy? Okay, so for this guy, then there's actually a point that is validated, right? So since 2 minus 1 is actually smaller or equal to 1, we can actually use this as a pair. So what is the point? What is the maximum value of the equation? It is going to be 0 plus 3 plus 2 minus 1, right? And that's going to be 4, right? And how about this guy? We can use this pair, right? And what is the maximum value? What is the value of the equation? 10 minus 10, 10, that's 0, 6 minus 5, that's 1. Okay, so the idea is actually very simple. We are going to maintain a queue that's going to be in the form of, basically, queue is going to be in the form of a point and then x-axis, right? And then this is going to be a max heap. This is going to be a max heap. So for each endpoint, we are actually going to find the point that is the largest. That's going to yield the largest point, and then has the validated x-axis. And if it's not a validated x-axis, then we are just going to pop it out, right? If it's a valid x-axis, then we are going to take this point plus the x and the y of the current ending point, because actually if you see this equation, right, if we consider any point as an ending point, then we are actually going to take the ending point x-axis minus the other guy's x-axis, because this is going to always be larger than the previous x-axis, right? So for every ending point, we are going to cut out the irrelevant point mean the current x minus the previous x is actually larger than k, right? And then take total point plus x, current x plus current y as the point, the max point, if we are taking this as the ending point, right? After that, we are going to push the current point into the max here, and that's going to be it. And the time complexity should be O n log n, giving n is equal to point length, and space complexity is going to be O n. So let's implement this. It should actually going to be pretty short. And points, we are going to initialize our result value, and we are going to set it into a very small value, in range n. First, we are going to cut out the irrelevant points, right? Q and Q 0, 1. Larger than K, hip hop Q, right? And then what are we going to do next? We are going to take total point plus current x plus current y at the max point. We're taking this as the ending point, right? So in case if there's anything in the queue, right, then the first value in the queue should be the one that's going to yield us the most value of point, right? And then we are going to do result is going to be equal to max result, and then the minus Q 0, 0 plus points I 0 plus points I 1. Okay, and then after that, the first thing that the last thing we are going to do is going to push the current point to max here, right? We push Q. We are going to push the point I x-axis as the second value, and what is going to be the first value is going to be the point that is going to be added into the equation if we choose this as the first part of the equation, right? And it's going to be nums I 1 minus num I 0. But since this is going to be a max hit, we're actually going to squish things up a little bit, and then we are going to reverse the sign, right? And that's going to be nums I 0 minus nums I 1. And then here, yeah, okay, that's it. And then last thing, we are going to return result. Hopefully it's going to be good enough. Points. Okay, and that's it. and as you can see, it's very efficient in both runtime and memory. I hope you guys understand the solution, and see you guys in next video.